So this is a pseudo-random bit stream generator, and it's a nice application for flip-flops. Here we have our asynchronous reset flip-flops, so that whenever reset goes low, the next clock cycle Q gets 0. All right. Now these last two outputs of the flip-flop are fed in through an XNOR, which means if the outputs are the same, it will give a 1, and if they're different, it'll give a 0, and it gets fed back in here. And what happens is it looks random. Now, when you know the sequence, right, you can figure out the next value. So it's not good for security, but it's a whole host of applications. And then to see the clock actually working, I'm going to set the frequency to 0.5 hertz, so it should blink every 2 seconds, and that way we can see what's going on. So right now when we start it, we're going to be in single mode. All right, and notice that the flip-flops just kind of randomly went to some value. So that little green means 1, blank is 0. So it went 1, 0, 1, 1. And so the output is set to 1. And you can see that it's synchronous reset, not asynchronous. I can press the reset as much as I want, and it doesn't change Q. When I do a clock pulse, you can see that, well, let's just walk it through. I have a 1 here, which makes in conjunction with a 0 here, would make a 1, which then makes a 0, which will read in a 0 on the next clock cycle. So that should go to 0. So this 0 should go here, this 1 will go here, this 1 will go there, and then I should read in a 0 when I hit this. All right, you can see everything's shifted. All right, now I have 1, 0, which still makes 1, which still makes a 0, so I'd read in another 0. Right? Now these are the same, so it should put in a 1. And it does. And so on. Now the thing is sometimes if all of these randomly come up 1, what happens is this becomes 0, this becomes 1, and it keeps feeding back in the same thing, and it won't oscillate. So this could happen if you build the circuit. So rather than just randomly turning it off and on and hoping for the best, we want to have a reset. The way to do that is to have the clock going off and on, and then do the synchronous reset. So click the switch to clock, and you should see this start to blink, right? And if it doesn't, sometimes you have to click that, and then it'll kickstart it. So you can see the data flowing and being fed back in. It's a linear shift register. Now to set everything to 0, I'm just going to hold reset and wait for a few clocks, and now everything is 0, right? And as soon as I let up, there's a 1, and then it goes there, here, here, which then puts a 0. And so every time that goes high, you would just read that. And that's how you would do this in time. And so if you didn't see, this LED would just look like it's going on randomly, right? And if you want to see it faster, you can stop, set the clock to 1, save it. Of course, you want to make your own copy of this project for that. Then we can start it again. Now, right, see how this time, even though this was set to to run off of the clock, it's not starting, just click this button here. And I'm not quite sure what's going on. All right, so I guess you have to turn it off and on again or something until that blinks. And now it's blinking once every second. Right. And this is a great way to generate data to test telecommunications equipment because you know what the data is supposed to be, so it's easy to check. Sorry for that last bit, is that when you change the clock frequency, like we can make the frequency 2, right? Save it, run. It's not really going. So I turn the clock to this one and turn it back, and now you can see it blinking faster and everything moving. And this was great. I'm glad for this mistake because notice it all went to 1, so it won't oscillate. So I have to click my reset, and now you see it work. So it happened right there. Thought I wasn't going to get to capture it, but there you go. Have fun.